Today we are going to cover section 11.3, histograms and shapes of distributions. And you guys have built histograms back in 7th and or 8th grade. So a lot of the concepts that we're going to learn today, or we're going to cover, you've learned it before. So this will be just a refresher. So go and write down your title, write down your essential question. How can you represent and analyze data using histograms? Go ahead and pause it if you need more time to copy it down, or go ahead and paste it. So a histogram is a bar graph that shows the frequency of data values in intervals of the same size. So therefore, each of the bars will have the same size. So we're going to look at one on example number one. We're actually going to build example number one, number two, and number three. A histogram is another useful data display that shows the shapes of the distribution. Now, if you guys remember, the way that we have represented data and analyzed them, on section 11.1, we use a dot plot to be able to analyze the data, and then we calculate the mean, median, mode, and the range. On section 11.2, we analyze the same data using a box and whisker plot. And today we are going to analyze the same data using a histogram. So those are three different ways that we can actually represent data, and each one is used slightly different in different concepts in math. Now the histogram is going to tell us easy to be able to decide what is the shape of the distribution. We're going to easily see whether it's skewed to the left. Notice that whenever it's skewed to the left, that means that the tail is on the left. Whether it's symmetric or whether it's skewed to the right, that means that the tail is on the right hand side. So just kind of reference those three histograms whenever you're answering your questions on your homework. So let's go through example number one. So a reality cooking show selects 24 contestants. So we have 4 times 6, we have a total of 24. The ages of the contestants are shown in the table. Make a histogram and then decide the shape of the distribution. So let's go through a process of creating a histogram. First, notice that many times they are going to give you the range for each of the bars. So the first bar, it will be from 19 all the way to 20, so 19, 20, and 21. The second one will be from 21 to 24. And each of them, notice that it's 19, 20, 21, 22, 23, 24, 25, 26, 27. So each of them are three numbers. And just like it shows above, the intervals must be of the same size. But we've already done it on example number one and example number two. Now, we need to be able to place a tally for each of the numbers. So for example, 20 is between 19 and 21, so we're going to place a little tally. 19 is also on the first, and sometimes we call this buckets, so it's the first bucket. 25 is not until the third bucket, so we're going to place a tally. 27 is on the third bucket. 30 will be on the fourth bucket. 21 is on the first one. And we're going to continue for each one. 29 is between 28 and 30, so it's on the fourth bucket. 22, 27, 29, 20. So go ahead and pause it, finish up, and see how many tallies you get for each one. 31, 25, 20. And what happens if I have the fifth one? Correct. The fifth one, we place a bar across. So it'll be easier for us to count. 22, 23, 39, 32, 19, 27, 25, 22, 21, 24. So therefore we have 5 and 2. The frequency will be 7 for the first bucket from 19, 20, and 21. From 22, 23, and 24, we have a total of 5. We have 6, 3, 2, 0, and 1. And now the table's already built for us. So what we're going to do, we're going to highlight these numbers on the left. Those are the numbers that are going to go at the beginning of each of the bars. So there will be 19, 22, 25, 28, 31, 34, and 37. And now we are going to build the first bar is 7 height. The first bar is 7, so I'm going to go all the way up to 7. So I'm going to go and shade all the way up. And you can shade, or you can also use your highlighter if you want. Might be a little easier. I'm just going to shade my way through it. The next bar is 5. So I usually place a little bar to remind me that's 5 high. The next one is 6. The next one is 3. The next one is 2. The next one is 0. And the last one from 37, 38, and 39 is only 1. So there's a few things that you want to make sure that you keep in mind. So there's a few things that you want to make sure that you keep in mind is that this bar, the frequency is 7, and that corresponds to 19, 20, and 21. Then 22, 23, 24. So therefore this bar here belongs to 28, not to 31. So this is 28, 29, and 30. So therefore this number 31 belongs to the one on the right. The 37 belongs to the one on the right. This 34 is now represented by this bars. So that's something that you want to make sure that you keep in mind. And now the only thing that we need to do is we need to be able to describe the distribution of the data. So therefore, the distribution of the data is a skew left, is a symmetric, or skew right. So notice that in this case, if we kind of place it kind of like a little bar, a little shape, this will be skew right. So therefore, we can just say that the histogram is skewed right. That means that the tail is on the right. So let's go to problem number 2. In problem number 2, it says the frequency table shows the number of raffle tickets sold by students on your grade. Display the data in a histogram, then describe the shape of the distribution. So take the time to copy it down, make a nice neat table, make a nice graph, and then we'll work it out together. Go and pause it. So notice that in this case, they actually already did the frequency for you. They don't provide you guys with the raw data. They have a table with your buckets and your frequency for each bucket. So therefore, we're going to go through the same process. We are going to highlight the numbers on the left, which is 1, 9, 17, 25, 33, 41, and 49. And now we're going to place our bars. And notice that in this case, I'm like, this do not fit. So let's go and change some of the numbers. Let's go make that a 6, this a 5, and let's make this a 0. So otherwise we're not going to be able to fit that height of the numbers. So now we can actually make it fit. So let's go through and make a bar. So the first one is 5 height. And we are going to shade it. The next one is 9. So even though there's only up to 7, I'm going to make 2 extra ones. 1, 2. And I'll say this is 8. And this is 9. So just in case sometimes the pounds go a little off your chart, you can just go and draw one more. The next one is 6. The next one is 5. The next one is 0. The next one is 8. So 6, 7, 8. The last one is 7. And now we can answer the question below. Describe the distribution of the data. So we need to be able to decide whether it's skewed to the left, symmetric, or skewed right. So in this case, it's not either one. It's not skewed left, it's not very symmetric, it's not skewed right. So we can say the histogram is neither. The histogram is neither symmetric skew left or skew right. So it doesn't fit any of those 3 categories. So let's go move over to example number 3. Now example number 3, go ahead and glue your cutout and write down your problem. And then pause it, and then we can start once you are ready. So choosing the appropriate measures. Now one of the things that you guys will be seeing this is in Algebra 2. You guys will be taking a whole chapter on this, and then as a senior you can actually take an entire class on statistics. It says, use the shape of the distribution to choose the most appropriate measures of center and measures of variation. Now remember, your measures of center is your mean, median, and mode. Your measure of variation is your range. So therefore, if it's symmetric, your mean will be more appropriate to be able to describe the data. If you skew left or skew right, your median will be the most appropriate. So in this case, your mean will be the one that's going to be the most appropriate. In this case, your median will be the most appropriate if it's skewed left or right, because your mean will not be at the center, it will be a little more towards the tail. So just make sure that you highlight it, mean, median, and median. And let's go and place a little X in here, just so we know that's not the mean, and that's not the mean. So it says the police officer measures the speed in miles per hour. So if you haven't had a chance to copy down the table in the word pile, go and pause it. In miles per hour of 30 motors, and we have 30, 10 in each column. The results are shown on the table on the left. Display the data in a histogram using 6 intervals, beginning with 31 to 35. So let's go ahead and make a table of values. You can use your ID, or you can use a ruler, or just a straight edge will be fine. So let me make enough space so I can write down 31 to 35. Those will be my buckets. Those will be my intervals. Then I'm going to place my tallies here. Then I'll be my frequency at the very end, where we can just count the tallies. The interval. So the first one should be from 31 to 35. So from 31 to 35. So you have 31, 32, 33, 34, 35. So therefore there should be 5 numbers. So the next one will be from 36, 36, 37, 38, 39, 40 through 40. So therefore the next one should start with 41 through 45. Then 46, 46, 47, 48, 49, 50. Then 51 all the way to, let's say 51. So let me from 51 all the way to 55. And we need 6 intervals, so it'll be from 56 all the way to 60. And now let's go through the tally. So 31, and go and pause it, draw your tallies, your frequency, and then we can compare our data. Got it? So 53, 56, 50, 55, 51, 54, 52, 55, 45, 44, 38, 41, 50, 45, 53, 60, 50, 40, 58, 39, 48, 42, 55, 49, 52, 55, 52, 60, and 47. Did I miss anything? So we should have 1, 3, 5, 6, 11, and 4. And notice that just by having the extra cross section, it really speeds up the process of counting them. And now let's go and build our histogram. So in this case, we're going to highlight all the numbers on the left, which is, we're going to write them down. That'll be the first number, 31, 36, 41, 46, 51, and 56. And now let's go and place our bars. We have 1, we have 3, We have 5. We have 6. We have 11. Now for 11, I'm just going to make 4 additional ones. So 1, 2, 3, and 4. This doesn't have to be perfect. We're just going to label that there are 11 and we'll label it in pen. So I remember that this is 11 high. The next one we have 4. So we display the data in the histogram using statistics intervals, which measure of center and variation best represents the data. So in this case, we can see that the histogram is skewed to the left. So B, histogram, skew left. That means that your tail is on the left hand side. And letter C, the speed limit is 45 miles per hour, which should be here. How we interpret the results. So is this, according to this, is this the average of the scores? Is a good representation? No. So in this case, this is a little lower than, so 45 miles per hour is lower than the center of the data. If it was about the same, I would say about 51 will be more of the representation of the data. Now, many times they're going to ask you to compare the distribution. So they're going to give you the histograms already done. I just need to be able to tell me whether one of them is skewed more than the other. So in this case, this is skewed left, skewed right, correct? So that's something that I always have to remind myself. The tail is on the right. So therefore, the median will be more representative of the data. This is more symmetrical. This is symmetrical. So therefore, the mean is going to represent the data, or the mean will be a better representation for the data. So this concludes the lesson. Have a great day, and I'll see you guys next time.